Okay, so you have a, so in other words, you now have what's called a continuous function on the real line of periodic 2 pi. It's periodic of 2 pi. So you have, so every function that's a continuous function is, you know, a continuous function is a function that doesn't have any breaks. Okay, now every such function you can be expanded in terms of Fourier series. A Fourier series is something that looks like this: a0 over 2 plus summation. You know what summation sign is?
Yeah.
N equals 1 to infinity. A n cosine x plus b n sine nx.
You lost me.
Oh no. You have a sub n cosine nx, cosine of nx plus b sub n sine nx. N equals 1 to infinity. So that's the sum. Okay.
Okay.
And then now it goes, and for the zero coefficient, it's a0 over 2. So every function f of x, which is continuous and periodic of period 2 pi, is equal to a summation like that, where you can figure out what the coefficients are. All right. So now, if you take the function, and so there's a particular formula that will give you the value of an and bn in terms of your original function f. So what you have to do is you get the an by integrating it against sine nx, against cosine nx, and the bn by integrating against sine nx. That's what a Fourier series is. So now for the function pi minus x over 2. So pi minus x over 2 is not exactly a continuous function, but it's a function that's a straight line. Pi minus x over 2 on the interval is like it's a function like it goes like this and like this with a break. All right, and this is the way to figure out what the value of pi is. So you take that function and you expand it in terms of a Fourier series. And then if you set x equals 0, you get the value of pi minus x over 2. If you set x equals 0, you get pi over 2. So you have the value of pi over 2 in terms of this Fourier series. And you compute this number that you have, which is an infinite decimal expansion, and that gives you what the value of pi is.
Excellent.
That's really the way they figure it out.
I believe you.
And that's what the calculator does when you put pi on the calculator. It gets hold of this series and expands it and computes it.
Mom, you did that when you were 12 years old? That kind of stuff? Wow, impressive. Very good. Thanks for the lunchtime conversation.
And what I was explaining to you was Fourier series on the line. Now, if instead of doing Fourier series, you can also do Fourier series on the plane. So the plane is you take a square which has one end pi pi and the other end minus pi pi. Okay, so you see a square like that? You have a square in the plane, which is pi pi over here minus pi pi minus pi over here. Then over here it would be minus pi pi. So down here it's minus pi. Up here it's minus pi pi. Up here it's pi pi, and down here it's pi minus pi. So that's the square, like that. Now if you identify the sides, so if you identify the sides of a square, you put it over like this, you have a cylinder. Then if you identify the sides of the cylinder, you can put it down like that and you get a tube. and so that tube is called a torus. So, so now if you have a function in the plane that is periodic of period 2 pi in each variable, then it's defined in the plane, and you call that a function on the torus.
That's not torus.
And so that's a function. It's a function on a rubber tire. And you can expand that in terms of sines and cosines. And that's what my book is about.
Wow.
In Spanish, there you go. If you see one of his good books, you go
Riveting.
and you grab it, but it's gone.
That's amazing, isn't it?
That is absolutely amazing. Thank you for that lesson.